Okay, so in this video, I'm going to give you a definition of what a scalar quantity is and what a vector quantity is. Then I'm going to show you two examples of the differences between the two to help you out. So when we look at scalar quantities, these are probably the ones that you're most familiar with. It's where we have a magnitude, or the size of something, or simply a number. But remember, it's with units, especially in maths and science. So when we look at vector quantities, they're very similar. Again, we start off with magnitudes of whatever unit we're trying to measure or find out, but we also have a direction on them. That's the differences between the two. So I'm going to give you some examples to help you out with this. So say for example, we're looking at displacement, okay? So I've got a friend and I'm going to walk to her house because I need to get my fitness up. So I'm going to start here at my house, I walk down these streets to get to hers and I finish over here. Now each of these lengths is about 0.5 kilometers and I've got 1, 2, 3 and 4 of them. So 4 times 0.5 lengths. So my total distance is going to be 2 kilometers. This is my distance. That's how far I have traveled along the road to get to my friend's house. Now if we take the same start and end point, so starting and end point, and what we can do is we can draw a straight line between the 2 points, or it's also known as the crow flies. You may have heard that saying before. So this length in here is 1.2 kilometers, and that's my displacement. Displacement is just the straight line from my starting point to my end point, how far I've moved. But this isn't the whole answer because we need to put a direction onto it. So this is where we think back to our compass points, north, east, south and west. And this direction that I've walked in here, it's round about southeast. So my total displacement is 1.2 kilometers southeast displacement. So that's how far I've moved from my starting point. This is the vector quantity because it has a direction on it. This is the scalar quantity because it just has that magnitude. It doesn't have a direction at all. Okay, so the next example we're going to look at is where we have cars. So I've got my car, I'm travelling down the road and I've gone 5 meters in 2 seconds. If we work out the speed and velocity are very, very similar. So my speed from the textbook is the the change in distance divided by the change in time. So this one is quite easy. We've got 5 meters, remember we put our units on, divided by 2 seconds gives us 2.5 meters per second. And you should have seen this unit before as well. So that's our speed. When we look at velocity, hopefully you'll start to notice that this is a very, very pretty much the same equation. So again, we've got the change in distance divided by the change in time. So again, we work that out and it equals 5 meters over 2 seconds. Gives us 2.5 meters per second. But we've moved from the right, haven't we? We've moved from the left and we've moved 5 meters to the right. And again, if we look here, I'm trying to find a different color. This is a scalar quantity. If you want to think about speed, starts with an S as well as scalar, and V for vector and velocity. You can see here it's just got a magnitude, it's just got the number. This is the number, but it also has a direction on it. So I hope those two examples have helped you work out the difference between scalar and vector quantities, and I'll see you in lesson.